Hi guys, this is going to be the notes on pages 256 through 264, section 1 of chapter 9 about minerals. So hopefully you have already read through your section of the book that you are supposed to, and we're going to look at the notes for it today. I'm using the slideshow that is in your Google Classroom in your Rock Cycle Unit Materials tab. You want to make sure that you are using the slideshow to help you. It is not all of your notes, but it's a portion of them. So your book starts out with a definition of what minerals are. So to be a mineral, you have to meet these three criteria. There's actually more, but these are the first three and the most basic ones. So to be a mineral, you have to be inorganic. The word inorganic means a mineral is not made up of anything that's ever been alive. An organic material is something that at one point in time was alive or is currently living. Inorganic matter is matter that has never been alive. A mineral must naturally occur as a solid. So minerals aren't found in nature in the states of liquids or gases. And the third thing, which I just said, is minerals must be naturally occurring. This means that they cannot be created by humans. So minerals are naturally occurring, inorganic solids by definition. So if you go into the slideshow and you click present and you click on this picture, it says click on the picture for a song about minerals. It's kind of a fun link that you can go to, and it's just a review and a reminder of what minerals are. So again, to be a mineral, you must be a naturally occurring inorganic solid. So why are we talking about minerals in a unit on the rock cycle? Well, rocks are made up of a mixture of all different minerals. So in order to be able to understand rocks, we have to know what rocks are made of, and rocks are made up of minerals. Okay. So this is the book where you were reading, and so this is that first section on what is a mineral. The second page was about mineral formation. I told everyone in the Google Meet that this is not something that we're going to have on our test. There's different ways that minerals can be formed, but we're more concerned in our unit with how minerals combine together to form rocks. The next section of the book is all about properties of different minerals. So to identify minerals, we use their properties. Since rocks are made up of minerals, we spend a lot of time trying to figure out what their rocks are made of or what specific mineral we have. Each of these terms are a different property that helps us to identify what type of mineral we have. So if you don't know what one of these words is referring to, you're going to want to take notes on each of those. So I'm going to go back to the textbook for just a moment. So the first property that the book talks about are crystals. Minerals have what's called a definite crystalline structure. So if we could look at our minerals underneath a microscope, we would see that there's a specific pattern that the crystals form in, and it's different for each of the types of minerals that you have. The next two terms that your book discusses are cleavage and fracture. Cleavage and fracture are two words that describe the way a mineral breaks, or what's sometimes called a mineral's breakage pattern. Some minerals, like mica in picture A, or this halite rock salt in picture B, they will break naturally in smooth, flat surfaces. This halite is breaking smooth and flat in one direction. Sorry, that's mica. This mica is breaking smooth and flat in one direction. This halite over here, it's breaking in more of a cube shape. If you were to go into your kitchen and pour out some salt in your hand, you would see it kind of has a little cube appearance to each individual grain as well. So when we break in smooth, flat surfaces, the word for that is cleavage. When a mineral naturally breaks in a rough, jagged, an irregular shape or pattern, the word for that is fracture. So this piece of flint is showing us an example of fracture. Now I want to come back over to the mica. you can see that the mica is breaking in smooth, flat surfaces in one direction. But if we go around the edge of the mica, it has a very rough or jagged breakage pattern. So the mica actually has fracture around the edges in this direction, and it just has perfect cleavage in one direction. So again, how a mineral naturally breaks is described as either cleavage or fracture. The next term that we're looking at for mineral identification is color. Color is the first thing that we're going to look. Normally it's listed first. Your book did not list it first. Like you're going to see, that's a green mineral. That's a yellow mineral. These are reddish colored minerals. So the first thing that you're going to notice about a mineral is its color. But color is what's known as the least reliable indicator when we're dealing with properties. And the reason for that is color can be a little tricky. Like when the mineral is forming, if there are other impurities around it, the colors can completely change. So we don't ever want to identify a mineral solely on color because it is the least reliable indicator. For instance, in figure 5 here, all 4 of these samples are the exact same mineral, calcite, but they look different because they have different colors. Their other properties are all going to be the same. The next properties that your book have listed are streak and luster, and they put those together, but really streak should be with color. Streak is the powdered color or the true color of a mineral. Streak is what the mineral looks like when it's broken up and powdered and it hasn't reacted with its surroundings. To determine the streak of a mineral, you use an unglazed porcelain plate. It's this little white tile here, this white square. And you take the mineral and you scratch it along the streak plate. This mineral, the color is gray, but its streak is a brownish red. This mineral, the color is more blackish, but its streak is also a brown or a brownish red. The true color of these minerals is the color of the streak, not the one with the impurities that we see with the surrounding. That is why I say streak and color go closer together. Luster, however, is this second paragraph, and luster is referring to how shiny a mineral is. The shiny a mineral, more shiny that a mineral is, the more luster it has. The opposite of something being lustrous is it being dull. So if you look at our example over here, our gray mineral, is it very lustrous? What about our black mineral? Is it very lustrous? Out of the two, which one would you say is more lustrous? Definitely the one on the right. This black one is much shinier. It is reflecting more light, so it has a higher luster. The last property that we're going to spend much time with is hardness. The hardness of a mineral is referring to that mineral's ability to be scratched or to scratch something else. The Mohs hardness scale is used to help us identify what minerals we have. It is named after a scientist whose last name was Mohs. The Mohs hardness scale helps us to figure out the hardness of a mineral, and we do that by taking the mineral and trying to scratch it with a variety of objects. When you're doing a hardness test, usually the first thing you do is take your fingernail and see if your fingernail will scratch a mineral. If it does, it has a very low hardness, and that mineral is very soft. Then we'll go through a series of trying other things. If your fingernail doesn't scratch, we try a penny, and then a nail. The glass, you normally lay down a piece of glass and see if your mineral will scratch the glass. You can take different minerals and try to scratch them against one another. The more hard or the harder a mineral is, the higher the number it is on the hardness scale. And many people commonly are familiar with the hardest mineral on the Mohs scale because it's very common that you'll hear people talking about a diamond and how it's much harder than other minerals. Your book talks about specific gravity, but that gets a little bit higher into chemistry than I like to go into with 6th graders, so that's not going to be on your test as well. And then the next section on other properties is what I like to call mineral fun facts. So there are certain minerals that have really unique properties that set it apart from all the others. For instance, figure 7 is showing a thin piece of calcite. And if you look through a thin piece of calcite, you end up with a double image. So you can see that. But there are other elements or minerals that have specific properties unique to them as well, such as magnetite. It's attracted to a magnet. Or if you've ever had one of those Himalayan rock salt lamps, that's just a piece of halite. So you probably don't want to taste it, but you could because it's salt. So there are lots of minerals that have some really unique properties, and if your mineral has one of those, it's easy to identify it. Okay, so I'm going to go back to our properties of minerals slide. So these properties of minerals, if we could take and do a little test, we could have a lab situation in a normal year. We could go through and record all of these different pieces of information, and much like the picture of our little detective guy here, we could use our clues to figure out what minerals we have and what our rocks are made of. So again, why are we talking about this? Because rocks are mixtures of minerals. So your book goes into understanding common minerals at this point in time. The big thing that they're wanting you to understand is Earth, from our last unit, is a terrestrial planet. It's one of the 4 inner rocky planets. So our planet is made up of rocks. And what are rocks made of? Minerals. There are some minerals that are the primary components for rocks on this Earth. From there, they go into special minerals that we've placed a high value on. Often we call those gems or gemstones. They're specific minerals that when cut and polished along their cleavage planes, they have very high lusters. And they have a tendency to sell for a lot of money. So they talk about different gemstones and kind of what those are. But then they say the majority of the minerals that we use aren't going to be the high-end cut and polished gemstones, but they're going to be ores that we mine out of the rocks. So we take the rocks and we are able to mine and get the rocks, and then we can even go through a process where we are able to take apart and get specific minerals. And those specific minerals are used in many, many everyday items that we need around our house. So, why are we talking about minerals? They make up the Earth, specifically the rocks that we're going to talk about in this rock cycle. So once you've finished with your notes today, you do have an assignment in Google Classroom that's questions about minerals. You want to make sure you get that completed and turned in today as well. If you have any questions, send me an email.